All right, welcome. My name is Kathleen Rascone, Director of Academic Services. Excited to be here with our two faculty to talk about their research and interest for this next admission cycle. I'm going to pass it off to our first presenter, Dr. Nadya Peak.
Hi, everybody. I Can you all see my screen?
Yeah, we can see it.
Great. Hi, everybody. I am Nadya Peak. I am an associate professor in HCDE, Human Centered Design and Engineering, and I run the group Machine Agency, where we focus on the precision of automation and machines, but for creative practice of individuals. So we build robots, we do a lot of things in contexts like laboratories, also in manufacturing, with craftspeople. And we use things like computer vision, computational notebooks, and other tools that allow for automated decision-making to be able to make systems that support people in automating different kinds of tasks. Here is my group. Not actually everyone in the group, but people who happened to be at demo days last demo day, and my lab. Here we're teaching a workshop in the lab about using different kinds of machines. And I'm going to tell you about some of the different projects and some of the different people in my group so you have an idea of what we get up to. I have a page that's specifically about applying to the PhD program in my group. It just has some general information. I am in human-centered design and engineering, but I have also courtesy appointments in computer science, mechanical engineering, and electrical engineering. And so I can advise students in those PhD courses as well. And the trade-offs of that, I try to describe a bit on this page. There's also frequently asked questions, things like that. And so I guess a big part of research things that we do is we build machines. Here's a machine I built when I was a master's student. It's a milling machine that was made on another milling machine for making circuit boards. And one of the ideas that we adhere, or one of the concepts that we adhere strongly to, is the idea of open source hardware, being able to build things yourself so that they can be customized and made for specific applications, preferably in a way that helps you also save costs. So this is a milling machine made on a milling machine that happens to be made out of restaurant cutting boards. This is another machine I developed when I was a student. This one is, the idea we had here was, how can we make it also easier to use automation in different kinds of contexts? And so this is a portable machine that folds into a briefcase, and you can change the tool head. So you can use it as a 3D printer, or you can use it as a milling machine. You can use it as a pipetting machine, with the idea of what are ways in which we can reuse infrastructure of machines in different contexts. And also with making things yourself being a big part of the things we're interested in, because we think different contexts can vary very drastically depending on who you're engaging with. A scientist might need a really different kind of system than an artist. If someone is trying to make things in volume, they might be applying things in different ways. So we also try to make modular systems. This is a cardboard machine kit, a kit for making machines out of cardboard, with the idea that you could prototype machines really quickly, more like in an afternoon rather than over the course of a whole semester or a whole year, to see what you might use or need, or what you need to iterate on when you're designing different hardware systems. A big part of things being open source and things being accessible is not just designing things, but also documenting things. We study a lot of ways in which you can improve documentation to make it easier for people to replicate work, including open source hardware, which is slightly more complicated to replicate than open source software due to, having to build it yourself. And so we do a lot of testing of what kinds of documentation work, how can we interleave documentation and tutorial, things like that. One of the, I guess, popular machine designs that we work with is the Jubilee machine. This is developed by former PhD student Sonia Vasquez. And like PopFab, it's a tool changing machine. So it has a Maxwell coupling that allows you to pick up and drop off different tools. And by picking up and dropping off different tools, you can do things like having workflows that have multiple steps, where I could look at something with a microscope, then I could manipulate it with a liquid handler or with inoculation loop or something. And then depending on what happened in my work envelope, I could then make decisions of what to do next. And so to pair with our tool changing machine, we develop software that allows for this sort of rapid exchange of data and robot command, where, I don't know, setting up the machine is relatively straightforward. Those of you who are familiar with Jupyter Notebooks, which I assume most of you are, you connect to your machine by just initializing your machine, and then you can declare different attributes that your machine might have access to, like maybe you have a pipette tool installed, maybe you have a 3D print head installed, etc. And then you can configure those tools for use in your notebook, control the motion of the machine from the notebook, and then also analyze the data that you gather with machine in the same notebook. And this, I think, we especially developed with scientists in mind, who are already doing a lot of data analysis in data science, things like computational notebooks. And one of the things that this also allows is for you to close the loop on different kinds of experiments. So we work a lot with chemical engineers and material scientists who are trying to optimize materials discovery experiments. And so this is a demonstration notebook that Blair, Brendan, and Maria developed, where you can have, for example, a target color that you want to create, and you have base colors that you can mix it from, and you can try to automatically derive the correct recipe for that color. The color mixing one makes it really friendly and easy to understand for people. Like, we demo this to middle school students, but you can quickly extrapolate it to other kinds of applications that perhaps are more relevant for material systems that are for things like energy storage or other kinds of materials that are highly performant that we might want to be doing high throughput experiments and automation for. And we also use the base Jubilee machine. So it's a machine where you can extend it with different tools that you can pick up and drop off. But you can also add additional functionality to it, perhaps outside the work envelope of the machine. So this is a machine that Danley Liu developed, who's a PhD student in my lab, where she augmented the machine with an additional reservoir to hold a material she developed that was made out of coffee grounds or spent coffee grounds that were inoculated with mycelium. And so when you 3D print something that is fully compostable, like coffee grounds bound with water and some binding materials, the subsequent print that you get is also often really easily destroyed, water soluble or crumbly or things like that. And the mycelium colonization allows you to make a much tougher material by harnessing, the work that the mycelium does in creating a biocomposite. But when you're trying to 3D print new materials like this, it's difficult to have existing off-the-shelf machines available that work really well with the rheology and different material properties of what you develop. And so she tried to make ways in which it was really easy to experiment with new kinds of materials that might meet different pressure regimes or other kinds of ways of making it easier to print. And she did some of this work with master student Jun Chaoyang. We also are interested in how designers might, so besides scientists and artists, we're also interested in how designers might want to work with automation. And one of the local companies that we work a lot with is McNeil, which creates the software Rhino Grasshopper. And so we have developed a library that's specifically for controlling machines within that CAD environment, Rhino Grasshopper. So you can move a machine around directly from Grasshopper. You can understand where your tool position is in Grasshopper, and you can use any Rhino or Grasshopper curve or geometry command to create motion instructions for your robots. So whereas perhaps those of you who are familiar with making 3D prints, you're like, okay, all the motion has to be determined in a 3D print slicer. Or if you're used to controlling a robot arm, you realize, okay, the robot arm instructions have to be created in some separate environment. And so what are ways in which environments where people are already used to manipulating geometry can be reused for things like controlling actions in physical space? So that's what this library is about. And then we also are interested in kind of the performative aspects of testing and iteration in machine. This is a system called P5.fab, which extends the popular creative coding environment P5.js with instructions that allow you to control a machine directly. And it also augments the environment with additional input devices. Here specifically, we're using a MIDI controller that perhaps a musician or a DJ might use when performing music, but instead of controlling sound, we're controlling print parameters like speed, extrusion rate, heat, things that perhaps geometrically are not necessarily as apparent what exactly is going to happen, especially if you're using different materials, but allow you to get really different print properties on the fly. And instead of using slicers where you're going from CAD to a specific idea of what exactly should be happening in CAM, it lets you access certain primitives and create your own abstractions for your additive manufacturing methods, which let you print in really different ways. This is Blair developing what he calls line bases, where instead of printing everything in uniform slices, he's using the ability to bridge long strings of 3D print by traveling at a well-tuned speed at a specific heat. So being able to explore the design space of material properties that are resulting from combining controlling machines from specific parts of code and low-level machine parameters at the same time. Something we're trying to explore here. Here it is sped up, can make bigger things. And I guess we don't only work in hardware. Some students specifically are interested in just creating software tools that help simulate physical processes. This is software developed by recently graduated PhD student Hannah Twigg-Smith called Knitscape. And it specifically helps people design knit and colorwork patterns. Knit and colorwork patterns which use slip and tuck stitches, which are something that is not necessarily as straightforward to visualize as some other forms of color knitting. And so she developed a topology model for describing the knit, or how the knit threads basically how the topology of the thread is for each knit, and then a simulation environment to show how the different colors would behave. This is actually not a great example of it because there are no slip or tuck stitches in this particular graphic, but if you go to knitscape.net, you can test it yourself and play around with the relax button, which is something I guess a lot of software should really have. So anyway, that's my research group. We work on a lot of different kinds of things. There's a lot of different people in my group. We have people from backgrounds like software engineering, physics, mechanical engineering. I really like all of those schools that are sort of general engineering specific for undergrads, like Owen or Harvey Mudd. I feel like people come out of those with very well-rounded engineering skills. But we also have people, there's someone in my group, Gabrielle, a PhD student, who has a background in French and continental philosophy. And so it's really wide ranging. I don't think that you should immediately look at this and be like, oh, this is for some other type of person. We have lots of people in the group. And I think the scheme is now, you can ask me 3 questions and then later you can ask me more questions. right, Kathleen?
Well, you ended early, so we might have time for 4 or 5 questions if
Oh, Lord.
needed.
Yes.
I see Alex has his hand up. You can go first.
I can stop screen sharing also, perhaps.
Can you hear me okay?
Yeah. Hi.
Hi, that was so fun. I in my undergrad I did technology, arts, and media at CU Boulder,
Cool.
and I had like an amazing makerspace fab lab available to me. But then when I moved out here, I found the experience was a lot more difficult to find one that had the same uh, where I felt as I could take them. And so yesterday I went to some of the other faculty presentations and heard some interesting thoughts on community from Dr. Hasselkorn. So I think curious, like what's your interest in exploring, like what makes a welcoming but also an empowering makerspace or Fab Lab community?
Totally. I guess, especially for open source communities, it's really important that, or like what we found at least, is that it's really important to acknowledge all different types of people who might be contributing to a project. It's not just people who perhaps are designing mechanisms, but it's people who are doing documentation, people who are flagging issues, people who are welcoming other people. These are all really important roles. And so research-wise, we often, I mean, we study open source hardware communities, and through those empirical studies come up with recommendations for things that we think people should do, things that maybe will be obvious to someone like you who already is embedded in some of these communities, but are surprisingly not obvious to people who maybe fund this kind of stuff, where it's not like, oh yeah, just buy a 3D printer and then everyone is going to show up and it's just going to be great. You might want someone who helps people use the 3D printer and also can fix the 3D printer. And so I guess research-wise, how we try to approach that kind of thing is through empirical work, like studying people. But I guess as a group, we also try to embody it in our own space. I have a shop that has equipment in it that all the students can use, obviously, but we also have artists in residence and visiting scientists and other people from the broader community that also come and use and maintain and contribute to that community. The University of Washington also has several large makerspaces that I would say we are active users and participants in. And then in those makerspaces, I also am the faculty advisor for, I'm very pro different informal learning environments like makerspaces. So I try to support informal student groups that want that kind of informal engineering education environment. So for example, I'm the faculty advisor of Wolf 3D, which is the student 3D printing club, which is a really awesome 3D printing club. They make all kinds of things and they involve everyone from first year undergrads to postdocs in different kinds of 3D printing projects. And, I don't know, it's very wholesome, but selfishly, it's also like a great place to recruit undergraduate researchers who want to work on projects. So we have a lot of undergraduate researchers that we find in the makerspaces hanging out. I don't know if that really answers your question, but.
Neat. Do you have other questions?
Yeah, there's an undergrad we found in a makerspace here, Shenna. Hi.
Hello. Nice to see you.
Good to see you. Yeah, Shenna did empirical work as an undergraduate in machine agency, studying people on open processing, the website where people share processing and p5.js computer sketches.
Yeah, it was a really great experience. Wonderful lab, wonderful people, lots of great support and resources.
You don't have to endorse the lab, Shenna. You should act in self-interest.
Okay, well, if there's no further questions at the moment, or people are still thinking, we will transition to our next speaker with Emily. And then at the end, we will open it up for questions from everybody. Do you want to take it over?
Yeah, absolutely. Hitting share. Oh, weird. Sorry, it's not telling me what desktop is which, so I'm just gonna figure this out. A fair warning before I get started, I'm a little sick right now. I think it's probably COVID, but we'll see what happens. So if I start coughing in the middle of this, just act like it's not happening. Okay, if I share, I'm scared. All right, sorry, I have to enable sharing somehow.
There should be a share button at the bottom of your controls.
Yeah, I think Zoom just updated
Oh, no.
because of course that would be the time that it decided to. Um, okay. I have to quit and reopen Zoom, so I'm gonna
Okay.
quickly go do that. Okay, sorry about this, y'all.
No worries.
All right.
So in the meantime, anybody have general questions about the application? Really great time to have a professor here to be able to give their perspective. Could be on essays.
I can give you guys general recommendations about PhD if you don't have questions.
Yeah, go for it.
I think that, well, I think that lots of people are like, oh, this school has this or this other school has that. I think you really need to consider who you're going to be working with, because you end up working a lot with your advisor. And you might not know immediately who your advisor is going to be. However, it's like something that is very important to think about. And so if you're thinking about applying to HCDE, you should really learn a lot about the people you might want to end up working with. I don't know, the PhD process is long. They're typically, I don't know, 4 to 6 years, or if you were me, more than that. And they are still, however, temporary. So it's not, it seems long, but it does end eventually. And after you do a PhD, you go and do something else. And so it's important to think about, what are you going to do after your PhD, and what is going to set you best up for success in that goal. You might not totally know exactly what that goal is, but maybe you definitely know things that you don't want. So you think about PhD training period, long, set you up for future. I know Yuan Cheng has a question, but Emily is going to start, so maybe we should save it for later, or is it a quick question?
I can save it for later.
Okay.
Okay, all right.
You're ready, unless you need more time.
No, I'm good. I just now don't know where anything is. And my camera's not on, is it? That's great. Sorry, y'all. Oh, there we go.
Here you go.
Okay. All right. Are y'all seeing a slide with my face on it? Okay, great. Hi folks, sorry about that. But thank you all for your patience. This is not going to be quite as beautiful or nice as what Nadya just presented. This is because I'm starting in the fall of 2025, so I don't have quite as much work to show, but very happy to talk about sort of my aspirations for the lab and the types of students that I'm hoping to work with and the type of research that I'm hoping to accomplish. Okay, so I work in a community that we call digital safety. This is a field that sort of spans human-computer interaction, and that includes things like CSCW, social computing, plus computer security and privacy. And the general premise for the field that I work in, we have all these big societal problems. So things like gender-based violence, which is where I did the issue I did my PhD in, things like civil rights and democracy, which might be top of mind for us in the States at the moment, racism, sexism, bigotry, these big problems. And we also have these new technologies that are creating these new vulnerabilities. So things like personal computing, social media, and this laundry list of other random techie buzzwords right now, creating things that seem to exacerbate some of these harms. And to me, this is a bunch of socio-technical questions that also present engineering challenges. The premise of what I do is that there's something we can do in engineering design processes to sort of mitigate and perhaps even and help people overcome some of these inequities. So core questions tend to be things like, what makes different people feel safer or more vulnerable in their technology experience, and how do we design technology in the face of diverse vulnerabilities? Methodologically, I tend to do a bunch of stuff, very mixed methods. So the process tends to look something like this. there's going to be some set of empirical work. And by empirical, I mean that could be either qual or quant, if that's something that folks are worried about, to sort of investigate how technology is playing a role in a certain type of harm. Then we'll build interventions. Intervention here means shore systems, if that's your speed. I spent a lot of my PhD working in sort of a clinical service, helping survivors of domestic violence. That's also an intervention. So taking sort of a broad scope to what sort of an engineered intervention can look like, and working with communities to deploy that, test it, do all of that. And then there's a large part of what I'm interested in, and hopefully you are too. There's this premise that if we put interventions out there in the world, we have a better way to sort of learn, sort of on the ground, in situ, how this harm is taking place. Things like clinical research might remind you of this. And that poses all sorts of ethical problems too, that I think the field is starting to wake up to. So between these three things, lots to work on, depending on the population, the issue, and a lot of intertwined research threads. In terms of values and venues, which I mostly just bundled because they alliterated. For venues, I work between HCI and design, so really familiar with places like CSW, Chi, and DIS. Computer security and privacy, there's a couple of venues that are excited about this work, Usenik security being the most obvious one, and definitely part of a community of some of the folks who are curious about expanding how computer security and privacy thinks about security and privacy. That tends to be where those folks sit. And I have increasingly a bit of an imprint in this space around AI and AI ethics, so FACT and AIES. And in terms of values, these are sort of the three core things that I think come up in my research a whole lot. How do we do community engaged digital safety research? So, you might have familiar themes around participation and community engagement and design. How do you do that when the problem is safety and there can be multiple constituencies or user groups, if you want to put it that way, who might disagree, who might consider each other a threat? How do you manage things then? Second, how do we do digital safety research centers awareness of power? This is hopefully can pull on theories and ideas that aren't just located in computing, but also more broadly in sociology and things like that to inform how we rethink computing. And then relatedly, how do we use our proximity to computing to redefine its social impact? So for me, it's ideal if you think about computing as both an object of inquiry and a community that you have at least a toe in, because the idea is to sort of co-opt some of the money and energy that goes toward it to do better things. This is a laundry list of some topics that I would love to field applications for, sort of in order of proximity to my existing research agenda. So from the top, computer security and privacy in this modern and surveillance. I have this theory that digital safety should be considered a health equity issue. If that resonates with you, would love to chat. We have a lot of work around what we call safer research infrastructure. So redesigning how we study things like social media for misinformation to account for the trauma that might be incurred in that process. Is trauma the right lens? I don't know. Let's work on it. I have some work around community control over ML and AI, very related to the safety idea. We can't have people sat there staring at awful outputs all day just to make someone's LLM better. How do we do that in more respectful ways? And then going outwards from there, I have a lot of curiosities around mental health technologies, and then generally Asian Americanness and technology that I'd be excited to explore too. And then last slide, a couple of thoughts on who I'd like to work with and who I am as an advisor. We can talk more about this in questions. My take on scholarship is that this is a really cool protected 5-year writing job. And so ideally, you also would love to write, even when it sucks and even when it's hard. Something I think is really important is that you have a sense of what literature you want to work in, and what you want to think about, whether that's a field or a type of discourse that you want to contribute to. And I tend to work best with students who have, we'll call it like at least 3 of this list of 4 things. So analyst, writer, builder, organizer, and I can talk more about those roles. As an advisor, I think a lot about sort of building a lab culture where it's like, we are working together toward making something better. So I care a lot about feedback culture and stuff like that and how to make it work for everyone. Academia is a big, wide, weird world. And I think that an advisor is sort of your first ally advocate and do my best to sort of explain how it all works and help you through it. And then also your first line editor, and this is to reinforce the idea that this is a writing job. We're going to be doing a lot of work together, and editing is one way that I'll interact with you. The caveat here is I'm your first line editor in the research communities I know. I tend to work with students who have interest in other fields too. And that's great. But just setting expectation, I know best what I know, and I'm happy to work with folks about expanding outwards, but there's limitations to it too. That was all I had. Happy to jump around, and thank you all for coming.
That's great. Thanks for sharing. I know we're all really excited to have you join the department. And I think what's really cool about having you here today too is that you're a recent grad. So you've been through all of this. So all these students here who are trying to figure out, does this make sense for me? Is this the right place? You know, you have recent experience to be able to share insight into that. And I also find newer professors have more time to dedicate with their students. Most often. I wouldn't say that that at large is how it goes, but I do think professors that are building their labs and everything, they've got a lot of time to engage with their students and build out what that looks like. And so being new PhD students with a young lab too, you have a lot of bandwidth to kind of shape what it can look like, and that's really cool. Okay, let's open it up for questions for either presenter. I know we've got a lively chat going, which is great. Matthew. Oh, there you are. Thanks.
Hi, thanks. So Emily, with respect to your primary objective, this idea of sort of reimagining or thinking about computer security and privacy amidst surveillance, I guess my question to you is, do you expect to sort of do the work of reimagining theories of privacy and at the same time soliciting perspectives from members of vulnerable communities to do this kind of work? And then I think my second question related to this objective, do you think that this work will be primarily empirical, so using empirical analyses to sort of reimagine privacy and security, sort of conceptions of privacy and security, or do you expect that this will be more so interpretative work?
Yeah, great questions. So short answer to the first question, yes. I think for rethinking theories of privacy, a lot of the current literature basically has advanced that like privacy is maybe not the right frame, maybe vulnerability is the right frame. There's a great paper by Norm Macdonald, I think it's literally called From Norms to Vulnerabilities that looks at this. And a lot of the work, yeah, is empirical. It's working directly with vulnerable communities and making the argument from their experiences forward that what we're doing right now doesn't work and we can imagine better ones. I think that we could call it a theory of change, but like that idea that that's how we're going to do this theoretical work has some purchase in tech right now. So there's a bit of pragmatism to it too. There's some receptivity to hearing from vulnerable communities and using that to rethink privacy and security, and that's great. I think there's also a window. There's an equivalent window opening in the academic field, in the folks that I talk to a lot of the time across fields, to think about what we mean by vulnerability and embed that a bit more critical conscious of that into design processes. So basically, you know, merging a pragmatic awareness of what the tech industry wants to hear with sort of a more grounded, okay, how do we do this respectfully and bring in actual theory, literature, and history into how we imagine things differently, all whilst trying to work in a community engaged fashion. This is hard. There's a lot of ways to get it wrong, but I think that's kind of the idea, pushing through and seeing what we can try.
That's great. Thanks so much.
Okay, another question. I want to say your name right. Tulasi?
Yes, hi. Hi, everyone. My question is for Dr. Peak, and it's specific to applying to your lab. I have a background in apparel design with a master's that focused on functional design and wearables. So I was basically exploring digital fabrication as well as wearable tech. Would you be looking for students who have a heavier lean towards engineering as opposed to design? Or would a moderate skill set in engineering be something that you consider as long as they take classes during their study to further that?
You are a PhD student. I mean, I'm interested in people who are interested in making the kinds of research contributions that we make. And they're pretty varied. There are some design, some empirical, some engineering and systems contributions. And so I think it kind of depends also on what you want to be doing and what you want to be learning. If somebody came in, I mean, apparel design background sounds awesome. If somebody came in and was like, I have a background in computer science, but I'm really interested in doing mechanism design, I feel like that's a logical connection. You came in saying, I did apparel design and I'm interested in different kinds of fabrication. That also is logical. Sometimes though, PhD applicants come in with things that I find less logical, and then I need more explanation in your letter. Like if you have a bachelor's in cultural anthropology and you really want to do mechanism design, I'll be like, maybe explain that to me a little so that I can understand that I can support you in succeeding as a PhD student. But yeah, no, I don't know. I would say it's probably hard to avoid building things in my lab, but we don't necessarily always do it with the most rigorous engineering practices. Sometimes we use a lot of Scotch tape.
Thank you so much.
All right, I'll throw out a question. So, what do you look for in a research mentor? And it could be kind of thinking back on your PhD, but it could just be even now, like what you really look for, like when you think about picking advisors and how they can support you. What is it that you've needed? And either one can answer.
One thing I think I would really like to echo from something that Emily said is that you have to want to write things down. Because as Adam Savage from Mythbusters said, the difference between science and just messing around is writing it down. And writing it down is like a very important part of it. And there's different ways of doing that. One thing I think is really nice about the department, and is something I really value in not just mentors, but peers is feedback on writing and communication, and being able to share ideas through written form and try to really workshop how to make your positions and contributions clear through writing. And so, yeah, I think sometimes maybe there are people who come in like, I don't want to write papers. I just want to do things that matter. And sometimes, there are projects in which perhaps, you could imagine Emily's group making really valuable systems that help people who are currently maybe in dire need of help. But if you don't describe those systems or write about them, sometimes it's hard to even know that they exist and they have limited impact. So doing things and writing about things in the PhD is kind of the same side of the coin. And if you really don't want to write about what you're doing, it might not be a great idea to sign up for something where at the end of it, you have to write around a 200-page document.
Yeah, and riffing off of that, I think the other like latent thing that occupies your day to day that I realized toward the end of the PhD, it's going to be working with people, just like collaboration. This isn't really a field or an area or a department where sort of the siloed one person monastically going off into the wilderness to do their own research. At least in my group, that's not really what tends to happen. Everything from like saw this cool paper, think you could, um, a bit of a detour. There's a bit of a cliche that me and my academic friends talk about where, oh, we should write a paper together. It's like the equivalent of saying, oh, we should start a band. That's going to be your entire life, right? Like you're going to meet cool people at conferences and on the internet and stuff like that, and they're going to have really amazing ideas or work with really cool things, and you're going to be like, oh, we should start a band. We should write a paper together. And managing basically just a million bands and a million collaborations that you think are really cool with people who are at the same level, above the level, below the level, at different places in different environments. That's a skill that's like hard to learn. It's going to serve you in the future, but that's something the PhD I think is a really good place to focus on too. So I would say those two things: it's collaborating with people and then just writing all the time. Those are the things that I think a research mentor is good about helping you manage.
And that's even the first year experience. You get 2 rotations. So you're thrown into a lab, you're jumping on current student projects, you're trying to learn what research looks like in our department, trying to start your own research that might support your first milestone, the preliminary exam, which you could do at the end of your first year or beginning of your second. You're trying to get to know people, start to explore who likes the same research topics that you do, who looks like a collaborator or potential committee member. Um, so those are two great points. And I think too, a lot of our students who hit, between year 2.5, 4.5, maybe, they start to realize like, maybe I'm spending a lot of time on projects and things where I feel like I'm engaging with a lot of people, but I'm not doing the milestones or I'm not finishing up my coursework to actually finish the PhD. And that's where we try to help support and steer students so that you actually get through those next milestones and things. So we definitely don't talk about the writing expectations enough. So that's a great point. Any other questions? We're just breezing through here. Any other general questions about the application, program structure? Looks like we have one in the chat for Emily.
Yeah. Y'all hear me? My AirPods just died. Yeah, okay. Anyway, thanks for the question. I'll just read it. So for the topic of computer control over ML and AI, we're focusing more on data or on algorithms. I would argue you have to do both, especially data right now. And trying to focus just on algorithms without the data is sort of missing the point. So for me, it's both of those things. Great question, though.
Thank you.
Joan.
Oh, hi. Thank you for calling on me. My question is actually for Dr. Tseng, Emily. Mine is actually more regarding sort of like that interdisciplinary work, sort of across different departments. Do you have any projects in which you may be foreseeing collaboration across with different departments of any sort? I am asking mostly because I'm not an engineer in any way in my background. I'm more of like a clinical science person, and hoping to transition, but I'm hoping to bridge the gap between sort of like clinical healthcare science and also sort of data science things. But just wondering what that would look like, or if that is anything that you have interest in.
Yeah, great question. And I think the bridge you're trying to accomplish is super important. That's really cool. Short answer, yeah. I collaborate a whole lot with folks from other trainings, including clinical scientists, both PhDs and MDs from your world. So I've done a lot of that. I think that I'm thinking back. For me, I think the most successful collaboration there is, MDs have like a whole different publication game and way that they work, PubMed, stuff like that. So I have a lot of experience just sort of trying to make it mutually beneficial for both sides. For the student, it can be a little bit hard to straddle. So one paper that I did my PhD that like actually has the most citations of anything I did my PhD was like a JAMA paper. That's not useful for me, but it was very useful for my clinical collaborator, right? And I learned a lot in the process of writing it, but it was a sort of a different thing. So, I would say from the collaboration management side of things, for you, definitely. More broadly for interdisciplinary work, I don't think I said this. I should be able to co-advise in CS and also the iSchool. It's UW is a pretty flexible place for working between our three places for relevant tech and society scholarship. And that's something I'm really happy to do. So
Thank you.
Alex.
Hi again. I was wondering, as I'm working on the personal statement and like continuing to rewrite it 800 times, what do you, when you're reading some of those, do you have any idea of things that are frequently missed or you wish people would expand more on? For, for anyone.
Sometimes I think that people really care a lot about exactly how the research statement is written. Like they think a lot about language and they use the word, I am fascinated by something, I don't know. But really like research statements, we're reviewing lots and lots of PhD students, and it's not exactly as important that you have beautiful prose, that it's just easy to read your statement. Like it's clearly structured. This is your background. This is what you're interested in doing next. This is why you think this would be a good fit for you. Like I'm always reading statements looking for three things. Like, does this person have sufficient training up until now to be able to now take this next step? So have they done relevant things? Be they in formal training and education or otherwise? Then I want to know, like, are they going to be a cool part of the group? Like, do they seem like they are interesting and relevant? Do they want to be working on that kind of thing? And so that one perhaps is more vague, but still, like, you know, when you're signing up to be someone's advisor, you're signing up to spend many years with this person. So you want to have at least some indication that you're not going to hate them. And then finally, like, do they actually want to do this? I think a lot of people apply to PhDs without maybe a great idea of what a PhD is. And so I think especially people who are coming straight out of undergrad will say something like, I just love learning and I love classes. And so I want to do a PhD because I want to take more classes. Well, the PhD doesn't have a lot of classes. PhD has a lot of research. And so what you really want to do is take a lot more classes. Maybe you should do a master's or something else that is focused on that kind of thing. And so in the research statement, I also really want to know, like, do you actually want this? And to some extent, that means, do you actually know what this is? And so there it's also, I don't know, if I read a research statement and it's written in a way where it's very obvious to me that actually they're not necessarily interested in working in HCDE. We're just like some additional school that they're applying to, and the whole research statement is tailored to, I don't know, being in the material science PhD program at a different university. And then I'm like, well, this person seems really well equipped and they seem cool, but it doesn't seem like they want to be here. So I don't know what I want to do with this application. So even if they seem really strong, that doesn't necessarily mean that I would admit them, because I feel like I don't think that they actually want to be working with me. So those are the three things I think should be in the research statement. And I really wish people would think less about the pros and, like, I don't know, there's always like I was talking to my grandmother and then I knew that I needed to help society. And I'm like, yeah, grandmother is in all of your applications. Why?
Sorry, I didn't actually hear the question is like what we wish we saw less of in statements. Is that the
Or
question?
more of, I think.
Or more of, less or
Either
more?
or, yeah.
Okay. Yeah. For me, the big one is related to something I think Nadia actually said earlier. I want to know why, like, your wild curiosities, passions led you to like research specifically. The flip side of the grandma story tendency that Nadia is just describing is like grandma's experience could have led you to do anything. You could be an activist, you could be a doctor, you could be like literally anything in the world. Why was it doing a PhD and a PhD at HCDE in particular that you really feel like you have to do like right now? That I think people often miss because it tends to be just skipping straight from motivation into specific projects. And then I want to real quick give some voice to this conversation that's going on in the chat in the chat too about publications, whether they're necessary. Something I wish I saw a bit more of in statements, just to reinforce, it sounds like Nadia and I both don't care if you've actually published something. What we mostly look for is what the experience of trying to do a research project taught you, interest, enthusiasm. And then for me, something I really look for is it's like the voiceover of the project, right? So the example I give here, like let's say you did like a really cool machine learning project and learned something about how to exceed SOTA by like 0.5%. Great, that's fine. I want you to use the statement time to tell me what you learned from that. What thing did you get really motivated to study based on experience? Maybe it's like, oh my God, data sets are awful and bias results from this. Great. Like I want to hear that voiceover, you know? That I think is more worthwhile of research statement space than simply restating something that's on your CV.
Thanks.
All right, we have time for one more question. Who's been waiting to ask the last question? One popped in the chat. What makes a good fit in an advising relationship? Oh man, so many things. Go for it, Nadya.
I think it really depends. There's lots of different kinds of good fits. I would say all of my PhD students are pretty different. And so I advise them differently because it helps them succeed because they're individuals. I think things that are bad, I don't know, if some people talk about, you know, toxic advisors, and sometimes I think there's a lot more information about that from the student perspective than from the professor perspective. But as a professor, I'll represent the professor perspective there. I think that, you know, an open and frank communication is really important. I understand that things happen sometimes, and you know, you might have to cancel, or you might want to change direction, or but it's really helpful for me to understand and know about that, and also for students to realize that there are limits to our power as professors. We don't, you know, we can't change your whole life, and that's and that can be, it can be really tricky because sometimes it seems like the advisor relationship is so important. And so it seems like, well, if the advisor is also helping you with your publications, why are they not also helping you with looking for an apartment and dealing with your relationships and all these other things? And I think, you know, it's important that even if your advisor only accommodates some of your advice needs, that there are many people in your life that can fulfill different parts of advice roles. And so, you know, I have no idea exactly how to progress through the specific credit requirements of our program. Like I have a vague idea, but then I tell my PhD students, you definitely have to talk to Kathleen because it changes. I think you need 10 credits here, but I'm not sure when you have to, like, you know, sometimes you just have to ask other people, and there's plenty of people around that can help with advising, but you have to also communicate, I need this type of advice. And then I can say, oh, I can't give that advice because I don't know, but you can talk to Kathleen, or I can't give that type of advice because you want to publish in an area that I'm not familiar with, but maybe you should talk to Emily, or, you know, that kind of thing. So basically, I think there's lots of different kinds of good fits, but communication is a really important part of it. And respect is also a really important part of it.
Yeah, just to add to that, I'll say trust, because you want to feel comfortable asking questions, sharing when things are a challenge and things are getting hard and you need help, you know, and you're showing your writing to this person, and it feels very vulnerable. But it also goes the other way, and the professor wants to trust you and know you're going to meet deadlines, or if you're not going to, you're going to explain why you can't meet it, you know, in advance, and be able to share kind of your goals and make progress towards those goals. And so for, you know, I've seen advising relationships work where their research interests don't fully align, but it's because there's built trust. And that's super important. And then that person has approved the dissertation. So that's a big piece. Do you want to add anything, Emily?
No, I think that pretty resoundingly covered it. I just want to underline, because I feel like having most recently been a student, what makes a good fit, I think it's like professors have a lot of power, and I think students should just be very aware of what power they have also, sort of their role in the professor's overall program and stuff like that too. It's a mutual thing, but just, I don't know, I feel like I've taught a lot of students, and academia is structured such that it can feel very like one-sided. And that's like structurally true for many reasons, but I think in an ideal relationship, you're able to actually communicate as something closer to colleagues. So that'd be what I would say.
Awesome. All right. We're just at time. Thank you so much to everyone who showed up today. Special thank you to our presenters. appreciate you sharing your insight into this mystical, huge program that we try to do here. Deadline to apply, December 2nd. So get your apps in. We don't review early. You just have to get them in by the deadline. If you have any follow-up questions, I do drop-ins on Mondays at 4 p.m. Pacific time. And otherwise, thank you so much.
Thank you.
Bye, everyone. Thanks for coming.
Thank you.